Hello, everybody. How are you guys doing?
Good. How about you?
Good. Have you guys seen the fire? It's all over the news. The Silverado Canyon fire. Hope you guys are not affected. Hi, good evening. Okay. All right, let's give 1 or 2 minutes for those people who haven't joined yet. Anybody have any question regarding first project or homework? Anything? Because the first project is due this weekend, right? On Sunday, so probably you only have 3 days to do it.
Let's do Sunday at midnight, right?
Yes, it is. I set it to a Sunday to midnight, and which is this one. So you guys are all good?
Yep.
All right, great. So okay. We have 23. I think we're good to start. So as you noticed, or maybe not, I post homework number 5 on Blackboard, and this time I put the instruction below it. So pretty much this is sort of like an in-class activity. I want to do this because I realize maybe some of you guys haven't even modeled apart for a very long time, other than project 1, right? And the second project is going to be due soon after the first project, which is only, I think, a month in between. So I set this up. It's saying you're going to upload the screenshot of the model that created by following to this lecture, which means in today, we're just going to do one part, which is the engine block body. I'm going to do step by step, build it from scratch. And you're welcome to follow me, or if you're not really good at participating or just don't want to, you can watch the recording later and build it and take a screenshot of this body and upload it to Blackboard for homework number 5. So this one was going pretty well from in yesterday and Tuesday's class. Some people just follow along with the lecture and then take a screenshot like this. It doesn't have to be a isometric view. And just take a screenshot like this and submit it to Blackboard, and the homework is done for number 5. So up to you. Any questions about what I just said about homework number 5? So homework is always due the next week. So for example, I give a homework today, which is homework number 5, right? So the due date is next week. However, in syllabus, I do give you guys 2 extra weeks for late policy, right? So you have total of 3 weeks to do it. Apply it the same to all the homeworks. All the homeworks have the same rule. So pretty much homework number 5 is not going to do till 3 weeks from today, which is today, Thursday, 29th. So you're going to be 19th. And for homework number 4, the same rule applied. I think I posted last week, right? Which is going to be due 3 weeks from that date. Yes, exactly. All homeworks is due the next week. But the late policy gave you 2 extra weeks. So you can turn in late, it won't hurt you. But if you're trying to be even later than that, the homework going to be disappeared. You got no place to submit it. Just like from the Blackboard, you can't even see homework 1, 2, 3 anymore because those are gone. Any more questions before we jump into today's topic? Okay, there's no more question. There's one more thing I want to go over about it, which is this is the engine assembly that I showed you on day one. The animation, if you guys remember, still in the PowerPoint. This one is your goal to build if you don't have your own topic. Somebody is doing something else, they emailed me and I approved it, and for the rest, I assume you choose the default, which is engine assembly. So I'm gonna show all the components, how to model those in SOLIDWORKS from scratch, but it will be your responsibility to put them together. All right, I won't babysit you all the way from step one to this assembly. So I think it's fair enough. So I show you how to build every single component, but you need to make them together. So this deal, how does it sound? Let me know in chat. I asked Tuesday and Wednesday, and they all agree to it. What about you guys? Okay, thank you. Yeah, because I figure I should still leave something for you guys to work, right? Or put in some time, and because this is your model, this is your assembly, and with all your models, it should be your baby, and especially this is gonna be your first, probably your first CAD project in your academic career, I guess. So treat it seriously, and have your put some of your own thoughts into it. And another thing is about dimensions. So for example, in today's video, I'm gonna model this part entirely. And I will provide dimensions, which is used in this assembly. So you can choose either follow my dimension or come up with your own dimensions. But be careful, if you do choose your own dimensions, for example, this bore, the diameter of this bore is 2 inches. And if you want to go with 1.75 or 1.5 inches to have a small bore, you can definitely do that. But you got to change the other parts, for example, the piston, to accommodate this change. All right. So actually, I kind of encourage you guys to change the dimension. So in that way, you will know which part or the other components are associated with this dimension, and you have to change that as well. So that's kind of another learning process. So, but if you don't want to, if you just want to follow the video and do all the dimensions that I have here, is okay. Yeah, okay. You can definitely do that. But still be careful about the requirements. Like, for example, the 10 different components, that kind of stuff, you know. All right, so let's begin. Thank you. Hold on, open up a new one. All right, let's start. Okay, oh, okay, I forgot to go over this. So from this feature tree, you can see it has so many different features, probably 10 or a dozen of those, but they're all simple features. So nothing really scary. They're all either extrude or cut extrude or pattern and all that kind of stuff. So pretty much you guys have done it, or you guys at least have seen it in the previous lecture. Nothing scary as like, sweep or locted and something like that. So how does those simple feature construct this model? So let's move it to the first step, which is a rectangle. let's get the dimension of this part, which is 12 inches of length, 6 inches as width, and 7 inches as height. And let's do the same. Oh. All right, so this is a brand new one, and I'm gonna sketch and make it 12 by 6. Actually 12 by 7. 7 as height, right? And 6 is width. And let's extrude it to 6 inches, which is the width. Yep. So we have a block here, 12 by 6 by 7. And next step. Next step is a groove goes all the way through the bottom, which is gonna fit the crankshaft. And the dimension of this is radius of 0.5 inches, which is 1 inch in diameter. All right? And it goes exactly on the bottom, and this is a perfect semisphere. So let's pick one of the side, and we want to sketch right here, draw a circle. And if you move your mouse around, you can see the center point is already indicated right here. And you just pick the center point and then go to radius of 0.5. Or you can smart dimension it to 1 inch.
Hey, Professor, it's not recognizing like the middle of the bottom of the rectangle for me. Is there a way I can turn on to get it to recognize the middle of the edge?
Yeah, the edge? The edge is
Yeah.
recognizing you? Then you probably select something else as reference. You didn't select this surface.
Okay, I'll try that. Thank you.
Yeah. And let's draw a line, or let's use convert entity because we're gonna use this edge anyway, right? Let's convert the entity to sketch so you can see that entire the bottom line turns black, right? And let's trim all the unnecessary sketch. We just want the semisphere. And let's extrude cut it to form a groove. And let's go through all. If you don't want to go through all, you can go to the surface and just pick this surface. Both way works. And here we go. We have a groove at the bottom in diameter of 1 inch. And the third step is making 4 bores. 4 bores on top surface. And the dimension of these bores are 2 inches in diameter and 2.5 in spacing. And what is the center to? Oh. All right, the center to edge is 2.25. So select your top surface and you can sketch right here. So to ease it, we can draw a center line first so that all 4 circles are lying on the center line. All right. And set the first one to 2 inches, all right? And you can select all 4 circles by holding Control and make them equal. And dimension this to the side, which is 2.25. And keep dimensioning the spacing, which is 2.5. And here we go, we have 4 circles. And all we need to do is extrude cut it all the way through the bottom. So let's select extrude cut. And this time we can go through all. It's easier. We don't have to select any surface. So we have 4 holes and 4 holes, 1 groove. And let's keep going. So this step is just to create 1 axis and name it to be axis 1. Let's get back. The axis gonna be the center axis of this groove. So if you have this bar, you can choose the axis from here. If not, you can always search axis on the search bar, and the first one, sorry, spacing is 2.5. The 2.25 is the first circle from edge. So you pick the axis and just click anywhere, any part of this groove, and they will form you an axis. And click OK, it's already named as axis 1. You want this to be show longer, you can extend it. If not, you can just leave it whatever it was. And let's keep going. There's a cut revolve. So this part will be a little bit tricky. And let's show this geometry first. So the geometry is actually 4 rectangles. And we need those 4 rectangle revolve cut respect to the axis we just created, so that it will form these 4 half moon shape, this 4 half moon cavity. Okay? If you look here, it's 4 half moon shape, and the sketch is only 1 rectangle. And the rectangle is located exactly on the middle plane, right? In this case, which is the front plane. So whoever modeled this block is well considered, because he gonna create something on this middle plane. That's why the entire model is laying on the front plane. However, if we look at our model, since we didn't consider that, the front plane is by the side, it's not in the middle. Therefore, we need to create another plane called middle plane, and we're gonna do it right now, just in order to have our sketch, that 4 rectangle showed up on that plane. So you can go plane here or go search, and the first one pops up, the one with blue color, the blue filled in, and click that. So 2 ways to do it. First one, you choose your one of the surface of the front plane as your reference and offset it to this middle, which is 3 inches, right? Because the width is 6 inches. Or you can select the left surface first, and then select the left surface as your primary reference, and then the right surface as your secondary reference. And that's gonna yield you the exact middle plane. Yeah, the bore is 2 inches in diameter. So 2 ways to make middle plane, all right? So after we make one, you'll see this plane 1 shows exactly, the location of plane 1 shows exactly as the front plane in this model. And now we're gonna make the 4 rectangle sketches. So the first rectangle from the edge is 1.25. And the rectangle has a width of 2 inches. So 1.25, 2 inches, and the spacing in between is 0.5, and the height is 2.5. let's select this plane and ready to sketch it. And now you see is backward, but it doesn't matter. Okay. I need to convert some edges so that I can place my rectangle. Actually, let's do this. Wait. Let's just draw 4 rectangle whatsoever. And collinear these to the bottom. Sketch has been updated because let's deal with that later. Because I set this as coincide to break that. Okay. All right, now I can get rid of that, get rid of this, and get rid of this and this as well. Well, now we can dimension it. So this is 1.25. And this one will be 2. It's 0.5. Let's first set these 4 to equal. And set these to equal. Okay. All right. All right, this way we have 4 rectangles. And if we exit it, the 4 rectangles shows exactly like in previous model. And let's revolve cut it. And the axis of revolution, we select this axis. Wait, what's going on? It seems like the second one is not. Okay. Something happened in the second one, but anyway, let's try this one more time. And select the axis. Okay, this time it works. So we're gonna have 4. Wait, did I do? I think I dimensioned it wrong. For this side. Yeah, this one is what? It should be 2.5. Okay. All right, let's cut again. Okay, yeah, this time is good. All right, let's exit the cross-sectional view, and this is the shape that we wanted. And it matches exactly like this. So I'll show the dimension. The first rectangle from the edge is 1.25 and the height is 2.5, and the width is the same as bore as 2 inches, and spacing is 0.5. Okay, the next step. The next step is just making a hole. And this hole is located at the bottom. Is a quarter as diameter. If you measure this hole to the edge, is 1.25 to the edge. And to the left is 2.5. Wait, no, it's not. Oh, it's 1. Okay, so it's 1 to the left and a quarter to the edge of the groove. And let's do this. So select the surface and sketch a circle. And start dimensioning this to there. It's a quarter. It's a quarter as well for diameter. And to this edge is 1. Okay, now this circle is fully defined. How much deep? So normal distance is 1 inch. That means this hole is 1 inch deep. Extrude cut it to have 1 inch as depth. And this is the hole we just made. And from here, yep, same hole. All right, the next 2 features are about patterning this hole. So this linear pattern will give 5 hole, will duplicate this hole 5 times on the bottom side, and the mirror, which respect with the middle plane or the center plane, gonna give us another set of 5 holes on the top. So linear pattern first, and direction, we're gonna choose this edge because this edge is going from left to right, right? Or that edge, or this edge. They're all gonna work. And the spacing, if I remember correctly, is 2.5. Let's start over. I don't know why the numbering won't let me delete it. So it's 2.5 and total 5. So this is how we duplicate those holes. And mirror feature. So the pattern is already in here, which is the bottom 5. And let's choose this plane. So it will reflect those right into where we want it. Okay, so total 10 holes. So this step gonna give us another half moon cavity, similar to the groove, but this one won't go all the way through. This one only goes certain depth, which is 3/4. So the radius is 1.5 inches, which is diameter is 3, right? And only go in 3/4. Let's make this. Same theory as making the groove. So select this side and draw a circle. So this point is already ready for you right here. And you can just use that point and draw a circle. Make it 3 inches big. And we can use a line to connect the bottom to close this sketch so that we can extrude cut it. To trim the bottom. All right, so this semisphere has been made, and let's cut it. Cut it by 3/4, and this goes in automatically. You can see here, the preview looks good. And here we go. So this step gonna give us a hole right here. And this circular pattern gonna pattern the hole 5 times. And in this project, let's ignore those because those holes are not gonna contribute anything to our assembly. Those are just the details that the block body should have. But in this case, we're gonna omit it because it gonna do nothing but using a RAM. So let's keep going. This feature gave us a vertical rectangular slot. You see, this slot is used to have to place a chain that connects cam and crankshaft. But in this case, we don't have a chain, but we're still gonna make the slot anyway. So let's get the dimension for this rectangle. Okay. So the dimension for this rectangle is 3 inches in length and half of width, and also ½ inch from the edge of the bore to the edge of this vertical slot. And let's do this. Going to be on the other side of this groove we just made, or another groove, or the half hole. All right, so we place the center of the rectangle right here. We have this 3, we have this 1/4, and I'll have this 1.5 because the radius of the bore is 1. Okay, this is the dimension of this rectangle, and we can cut it all the way through. And here we have this vertical cavity. So I think the final step, and review the final step, which are the 6 holes on the top surface. So the cut extrude gonna make us the first hole, and after hole number 1, we pattern that 6 times out over the top surface. And the dimension of the top hole is diameter of 1/2 inch, and hole location gonna be at the corner, 3/4 from each edge. Okay, so select this surface and let's draw a circle. And let's put the circle dimension, which is 3/4. Another 3/4. This one 1/2. Okay. Circle is fully defined. And we need to find out the depth of this circle. Two inches as the nominal distance, say so. And let's have this cut extrude inward for 2 inches. Okay. All right, so hole number 1's here, and we need to pattern the rest 5. So let's get the dimension of this pattern. So 2 directions, therefore 2 spacing. The first spacing goes upwards, 4.5 inches, and the next one is towards your left, which is 5.25. So 4.5 and 5.25. Let's select this one, choose linear pattern, the direction 1, we choose this edge. You can see this is too many, we only want 3, which is 5.25 spacing. And direction 2 is up and down. This one is 4.5, and we need 2 in this direction. And we need to flip the direction and make it go on the top side, right? And here we go. This completes the block body, except for these little holes, because we don't need those, so we're just gonna ignore it. So how do you guys feel? Easy, right? With all the commentary, it only took me 30 minutes. So when you get familiar, it should only take you maybe 10 minutes or 15 minutes. And here you go. You take a screenshot of this, either this direction or that direction, whatever is your preference, and submit it to Blackboard. That's your homework number 5. Easy point, right? Okay. Yeah. So today we're just gonna do one part because I did some experiment on Tuesday's class and apparently it doesn't work. That's why I never mention it. People won't like to participate. So we just do this part, the block body, at this week. And next week, we're gonna do more. Therefore, in future, I'm gonna speed up a little bit. I'm not gonna be talking this much. I'm just gonna open up the assembly and pick the part, for example, the header, and just modeled it. And I'll stop for maybe 10 seconds or 15 seconds when there is something tricky. I want you guys to pay attention. And then I'm planning to finish all those components in 2 weeks. So I'll leave you 3 weeks to finalize it and put it together and turn it in. How does it sound? Well, this is, somebody asked me, will you show us how to connect the different parts into assembly? This is, I asked at the beginning of the class, because I'm gonna show you the way how to make all the components from scratch, but it will be your responsibility to make them together, turn it into an assembly, because I still want you guys to do something on your own, right? And assembly wise, from previous class, you can see from the previous recording, I already construct a very simple assembly and tell you guys how to make, how to offset, and how to coincide and all those kind of stuff. And so that was the deal. I asked the class and majority saying, okay, that sounds good. So I'm not gonna show you how to how to make parts. All right, any question? So if not, then we're gonna end class right here. The rest of the time you can use to do a project 1 because it's gonna do in 3 days, right? And or if you have completed, you can model this engine block body right now and turn it in the same night for homework number 5. So if nothing's, if nobody gonna ask anything, you guys are totally free to go. Enjoy the rest of your night. Thank you, guys. Sure, if you have specific question on your project, you can ask now. Thank you, guys. See you next week. Don't forget the project 1 and homework number 4 and 5. Yeah, sorry, speak up, please.
Okay. So for my project 1, I'm trying to do some extruded cuts through it all, and I have 4 separate holes that I'm trying to cut through a cylinder, and I have all 4 of the circles drawn out, and when I extruded cut one of them, all the other 4 disappear, or the other 3 disappear.
The other 3, you mean the sketch disappeared, or
yeah, the sketch disappears. So like I have a sketch with all 4 of them, and I'm trying to extruded cut all of them, and it'd only do one of them, and then the 3 other sketches disappear and there's no hole made.
Is that because the extrude cut you make is too big and covers the other 3 and cut all 3 materials already?
No, it's like
you can share a screen. I will.
Okay. I have it like I'm on Zoom on my iPad, and then I have it on my computer, so I'll flip my screen really quick. Oh, it's like I have this right here, and I go to extruded cut, like just this one specifically, and I'll extrude it all the way through. And then I'll do that, and then I go to extrude all the other ones, and then when I go to click on them, like they don't register, and then they like disappear.
Hold on.
Like that.
No, I can't see it now. Give me 1 second. Okay.
Wait, can you see my screen?
Yes. How can I make it bigger?
I think you can pin my screen to.
So kind of like, hold on, like